Hello class, this video lecture is on Chapter 6, Interest Rates and Bond Valuation. So after this video lecture and also learning Chapter 6, you will be able to compute bond values and yield to maturity. This chapter also teaches you what bond features and bond markets are, and also the relationship between inflation and interest rates. After learning this chapter, you will also learn a new term called the term structure, and based on that term, you will be able to understand the determinants of bond yield as well. So these are the sub-chapters of Chapter 6, and this video lecture will deal with 6.1 bond and bond valuation, 6.6 inflation and interest rates, and also in 6.7, which is determinants of bond yield. But also 6.2, 3, and 5, these subchapters are very important as well, so you might as well just catch up with these materials on the textbook. So recall the important keywords related to time value of money from Chapter 4. So from Chapter 4, we learned how to compute the present value and future value based on the interest rate, the number of periods, and also if there were multiple cash flows, payments were important ingredients there as well. So this was the basic timeline or basic structure of time value of money. And Chapter 6, especially with bond valuation, we would be just utilizing this structure, and also the concepts and the definitions would be very much related to the time value of money keywords as well. So let's move on to the basic structure and keywords of bond valuation. So first, we will have to start with the timeline, and then for this timeline, of course, you had to have some kind of interest rate, right, or discount rate, and that would be called yield to maturity in this chapter. And the definition or the meaning of yield to maturity is what's used in the market as a discount rate or required rate of return. So we just accept it as like what's prevailing in the market for any kind of assets or any kind of investment vehicle which has a very similar characteristic or risk structure. And then it also has to have a timeline, right, or a number of periods. And in the bond setting, it's called maturity. So years until this bond must be repaid. It's called the maturity. And another important ingredient here is future value, like how much you will be able to collect at the end of this time period or maturity. So it's usually just written on the face, or it's what's called the indenture, which is like a contract, and that is the face amount to be repaid at maturity, and that name would be par value or face value. And also, regularly, you will be collecting some kind of interest payments, and interest in the bond structure is called coupons. So the regular interest payments would be coupon payments, and you will be collecting them regularly, which is more like payments in time value of money setting. And with all these keywords and ingredients given, most likely when you are valuing a bond, you would be looking for how much you will have to pay for it right now, which is more like figuring out the bond value or the present value of all of these cash flow streams. So current bond price is called bond value or price. And as you saw before in Chapter 4, this is just located in time 0, right? So this is like looking for or figuring out the present value of all these cash flow streams. So let's just look into more details of those basic keywords. So par value or face value. This is the amount to be repaid at the end of the loan term or at the end of the maturity. And usually, it's not always, but in general, if the denomination is $1,000 for corporate bonds. There are a lot of bonds that have different denominations, but to make things really easy for an undergrad class, in this class, if nothing is said, then the default denomination or default face value for a bond would be just accepted as $1,000. And the next term is maturity. So maturity is, once again, years until the bond must be repaid, so it's like a timeline. And the third keyword would be coupon rate or coupon payment, anything that has to do with the regular interest, which is the coupon. So a lot of times when you are just trying to invest in a bond, you would be given the coupon rate. So what's written in the indenture or the contract would be the coupon rate, and that is the stated interest rate. So coupon rate is more like how much you're getting as your coupon annually divided by the face value. But as I told you, coupon rate is what's going to be provided to you on the contract term. So if you wanted to figure out the coupon payment, that will be face value times the coupon rate. So supposedly, let's say in your contract, let's say it was given as the coupon rate was given as 5%. Then by default, this is just multiplied by the face value, which is often $1,000. So what that means is every year, annually, you'll be collecting $1,000 times 5%, which is $50. So $50 would be your annual coupon payment. So in most of the problems that you will be coming across, they will provide you with the coupon rate. And it will be your job to figure out how much the coupon payments will be. And how, in real world, how is the coupon rate being decided? It's usually the yield to maturity at issue. Then you might be wondering what the yield to maturity is. Once again, yield to maturity is the market required rate of return, or like what's the prevailing rate of return for bonds of similar risk or characteristics and maturity, so on. Okay, so all these similar investment vehicles, how much rate of return would investors require or expect from those investment vehicles? That's the yield to maturity. So it's used as the discount rate to value the bond. And this is the return you would be expecting, you would be obtaining if you held the bond to maturity. And once again, as with all other like discount rates or interest rates you saw before, these are quoted as an APR. So nothing said, then yield to maturity, just stated as it is, it will be an annual rate. So put that all together. If we wanted to figure out, just use all these ingredients to figure out the bond value, then bond value can be just interpreted as the present value of all the cash flows, present value of coupons, and present value of the par value or the face value. So the first term is more like an annuity present value, whereas the second term is more like the present value of a lump sum or like a one-time single future cash flow. So you are trying to figure out the present value of all the cash flow streams that you see throughout the maturity period. So how would we be able to figure out the bond values with our calculator TIBA2 Plus? So you probably let's just try to match all these keywords with the keys on the calculator. So the first keyword, yield to maturity, this would be input as IY. And the second keyword, maturity, this would be input as N, or which is like the time period. The third one, par value or face value, that will be FV or face or for future value. And the regular interest or coupon payments, these would be PMT. So once you figure out what your IY and PMT, also FV should be, then with that, you're computing PV. And then that would give you what the current bond value or the current bond price should be. And note that when you are just inputting all these numbers, so as an investor, you're collecting the coupon payments and you're collecting the future value in the end. So that they would be input as positive values. And later on, when you compute present value, when you solve for present value, these will be output as a negative. Okay, so present value is what you would have to pay for. So that's cash out of your pocket, and this will be a negative value. Whereas future value and PMT, these are positive. So just keep that in mind. And there is another important thing that you should remember. the default is that you are collecting payments semi-annually. So this is like a semi-annual compounding frequency. So market required rate of return or yield to maturity. So for your IY input, you will be using half that amount. The reason is because you will be collecting coupons, and the coupons will be just compounded every 6 months. So every 6 months you will be applying half of the yield to maturity, which is quoted in an annual term. And for your time period N, you'll be inputting 2 times the maturity years. Often your maturity will be given as number of years. So you will have to transfer that back into like 6-month term. So you will have to multiply that by 2. That will be your input figure. And for your coupon payment input figure, you will be inputting half the amount of coupon payments as your PMT input. So coupon payments often is just computed by multiplying face value times the coupon rate. And coupon rate, as with yield to maturity, it will be given as an annual rate. All right, so you'll have to multiply that by half to figure out how much you're actually getting every 6 months, semi-annually. And then just inputting these amounts, you will be able to figure out the correct current bond price. So let's try to understand with an actual exercise. So Orange Corporation is planning to issue a 3-year coupon bond with a face value of $1,000 and a 6% coupon rate. So note that once again, a coupon rate is given to you, not the coupon payment. The bond makes semi-annual payments, which is the default. The yield to maturity of its publicly traded bond issued is currently 6%. Okay, so 6% yield to maturity, coupon rate is 6% as well. So the first variable that you need to figure out would be the number of periods. And number of periods, it was 3 years. That means it's, in terms of 6 months, it's 2 times 3, so 6 months. And for your IY, every 6 months, you will be applying half of the annual 6% yield to maturity. Okay, so 6% divided by 2 would be your IY. And for your coupon payments, regular coupon payments, so if you wanted to figure out the coupon payment, 6% coupon rate times the face value of 1,000. So 1,000 times 6% would be your annual coupon payment. And to that, you just multiply on 1/2 so that you will be able to compute the semi-annual coupon payment. So put that all together. So let's put that into your calculator. So 6 for your N, 1/2 of 6%, which is 3% for your IY. 1,000 times 6% divided by 2 would be $30 as your PMT, 1,000 future value. And let's compute present value, and that would be $1,000 as your output. So what that means is the current price of the bond is $1,000. And let's suppose right now you're just trying to figure out the current price of the bond as well, but let's suppose yield to maturity was 8%, not 6%. So there was an increase in the yield to maturity. Then the only thing that needs to be adjusted for would be your yield to maturity. So it's now half of 8%, not 6%. So as your input variables for your calculator, you're going to use half of 8%, which is 4% for your IY. If you just input all these variables in this order, you will have $947.58 as your output variable. Okay, so this will be your value. So currently, if you pay $947.58, that will be the adequate price or value for this bond. And by paying so much, you will be able to collect like $30 every 6 months, and in the end of this 3-year term, you will also be able to collect $1,000. And let's just try to move on to exercise 3. How much is the price of the bond if right now the yield to maturity or the market required rate of return was 4% instead of 6 or 8%? So the only thing that would be adjusted for here in this structure is that yield to maturity is half of 4%. So in your calculator, you're going to input 2% as your IY. If you did it, then the output you will see is it's $1,056.01, okay? So you will have to pay $1,000.56. You'll have to pay $1,056, and then you will be able to collect $30 every 6 months, and then $1,000 at the end of this 3-year maturity term.